Hi, hello, and welcome back. So to this, to anyone that's joining me, this is the second part of today's live stream, where we are looking at an Edexcel past paper for Level 2 Functional Skills. This is the second part because I lost internet in the first part, but what I'm going to do is we've got about 40 minutes here, so we're going to see how much of this paper I can power through. Now, we've already done section B. We've already done question 1. So let's see if we can keep going. So question 1 was there. So let's now have a look at question 2. Okay, so question 2 says that we have got a net of a 3D object. Draw a sketch of what this 3D object is. Okay, so let's see if I can... I'm just trying to see if this... I've just very quickly uploaded this live stream, so I'm just seeing if it's here. 1 second, I can't see if it's possible to be found. Maybe I'm not streaming it at all. Videos. 1 second. So, really sorry about this. But I just wanted to check that it's working. Yep, it is working. Okay, thank you very much if you're joining me. I doubt, I suspect that there isn't anyone, but it's good to get this done. So here we go. Yeah, so here is the net of a 3D object. Draw a sketch of the 3D object. Well, I can see that this is a cylinder, and it says here that there is a key, and it says on the key that 1 centimetre on the grid represents 5 centimetres in real life. So that means that that's 5, this is 5, this is 5, this is 5. So from here to here is 20 centimetres. And then if I go from here to here, I can see 5, 5, 5, 5, 5, 5. So that's 1, 2, 3, 4, 5, 6. So that would be 30 centimetres. The diameter of here is 5 centimetres. Oh no, yep, because that's a whole square. And so, yeah, so let me just draw it now. So really what I'm just drawing is I'm drawing a cylinder of length, this bit, because this bit wraps around, so we don't really need this length. I'm drawing a cylinder that's going to be 5 centimetres like this. And then the height of the cylinder, okay, will be 20 centimetres. So let's make that look realistic. So here we go. So this, from here to here, is going to be 20 centimetres. Okay, perfect. Let's try the next question. So question 3, the scatter diagram shows some information about the engine size in litres of average fuel consumption in miles per gallon in some cars. Okay, so here we go. We can see that this is a scatter graph, and we can see that it's got a negative correlation because it's going down like this. Okay, I don't know if I'm going to be required to do a line of best fit, but I've put one there anyway. Let's read what the question is going to ask us about this graph. So it says here that here is the information for another car. Engine size 2.3 litres, fuel consumption of 36 miles per gallon. Plot this information on the scatter graph. Okay, so 2.3 litres. Right, so I can see here that these go up in litres, so I can see 5 squares equals 1 litre. Okay, so if I divide both of these by 5 to get 1 square, I can see that 1 square is going to be, let's do 1 divided by 5, 0.2 litres. Okay, so each one of these small squares is 0.2 litres. So I want 2.3, so I'm going to want 2.5 of these squares. Now it says here the fuel consumption is 36 miles per gallon, and again here we've got, this time we've got 5 squares is 10, okay, because this is going up in tens, so that's easier. So 1 square will equal 2, so they're going up, each square is going up 2, so we're going to want to get to 30 and then go up 3 squares because 2, 4, 6. So here we go. Here we go, we've got that there. So I'm going to draw over to here. Okay. Oh, well, actually, I've put the point on now. That's all they wanted. So I've marked the point on there. So let me get rid of that last line. Okay, so there we go. We've got the point on the graph. Now it says part B, draw the line of best fit. Okay, I've drawn the line of best fit there. Notice that the line of best fit doesn't have to go beyond the graph. Okay, so in fact, it's very important that you keep your line of best fit to the data that you have, because although we know about these cars, we don't know about cars with engines of 6 litres, and we don't know about cars with engines of no litres. Not that you could get a car with an engine of no litres, I guess. So that's how the line of best fit should look. Part C. Michael buys a car with an engine of 4.2 litres. Use your line of best fit to estimate the average fuel consumption. So what we're going to have to do is you're going to have to make sure you draw these lines on to show that you've done it correctly. But what we're going to do is we're going to draw up to the line. Okay, and then we're going to draw across here. And we're going to see here, this to me looks like that is about 23. Okay, so I'm going to write that as my answer. 23 miles per gallon. Okay, right, let's keep going. Work out 3 cubed take away 4 squared plus 9 or plus 7 all divided by let me move the calculator over here. All divided by 2.5. So cubed means 3 times 3 times 3. Squared means that this is going to be 4 times 4. The plus, well, we know that. Let's work out what this bit is first. Okay, so the bracket we're going to do, so we've got 3 times 3 times 3. So that bracket is going to give us 27. Take away the 4 times 4. So I know that we know what 4 times 4 is, but I've got the calculator here, so I'm just being lazy. Oh, 1 second, I should show you what I'm up to. So let me put that there. 4 times 4, so 27 take away the 16. Okay, well, let's do that first. 27 take away 16, and that equals 11. So the top of the fraction now becomes 11 plus 7, and then we're going to divide that by 2.5. So 11 plus 7 is, so if I add the 7 to that, that gets me 18. So we've got 18 here, all divided by 2.5. So 18 divided by 2.5 will equal 7.2. Okay, so there we go. There is our answer. Right, part B. Write the following values in order of size. Start with the smallest. Okay, so I'm going to turn these all into decimals. Okay, so this is 0.5, so that's fine. 5 over 9 means 5 divided by 9. So that's 0.55. 4 over 7 is 4 divided by 7. Okay, 4 divided by 7 is 0.57. Okay, 47% is 0.47. So now I can start to look at which one of these is the smallest. So I can see that the smallest one is here, which is going to be the 47%. So let me just lift this up so I can write the answer in the answer box. So when you write your answer for this, you actually have to use the original numbers that they gave you. So we've got 47% is the smallest. Then the next smallest is going to be 0.53. The next smallest after that is going to be... Oh no, I missed out 0.5. Oops, right, sorry about that. So we've done this one, then we've got 0.5. Then we've got 0.53. Then we've got the 5/9. And then lastly, we've got the 4/7. Okay, perfect. Let's move on. Here we go, we've got question 5 here. And this says that Misbah is a midwife at her local hospital. She is writing a report about changes in the average weight of a baby at birth. Misbah is has this information about birth weights in 2018 at the hospital. Okay, so Misbah can use this graph to change between kilograms and pounds. Misbah wants to write about the percentage change. Oh, I need to move this. This is all a bit too... Here we go. Misbah wants to write about the percentage change in the modal weight of a baby from 1998 to 2018. She finds out the modal weight of a baby in 1998 was 7.7 pounds. Okay, so I'm guessing that they're going to want us to... Right, the question's going to be on the next page, but I'm guessing they're going to want us to find out the percentage change. So what is the percentage change in the modal weight of a baby from 1998 to 2018? You must write your answer to the nearest whole number. Okay, so let's go back here. So modal weight means the most common weight. Okay, so let's see which one of these appears more than once. Well, actually okay. Let's see which one of these appears the most. So I can see here that the weight with the highest frequency is 3.3 kilograms because this is the largest frequency. So the modal weight for this one is 3.3 kg. Okay, right, now if we've got 3.3 kg here, we now need to use the graph that they've given us to change from kilograms into pounds. Okay, so let's go here. We've got 3 kilograms here. We want 3.3 kilograms. They've very conveniently given us 1 square per point, okay, because we've gone up from 3 to 4 in 10 little squares. So I'm going to go up to here, read up to the graph. Okay, there we go. I can see that is going to be 7.1. It's always important to put these lines on because it shows the examiner that you've done what you were meant to do. So 7.1 pounds. Let me move the calculator over here. So that's 7.1 pounds. Now, we know that the new weight is 7.1 pounds. Let's move on from there. So it's gone from 7.7 to 7.1. Okay, so here we go. We've gone from 7.7 pounds to 7.1 pounds. Okay, so we can see it's reduced in weight, but it wants to know the percentage change. Okay, so the percentage change is calculated by finding the actual change as a percentage of the original amount. Okay, so we can see here from 7.7 to 7.1, that is a change of 0.6, and we can get that on our calculator. 7.7 take away 7.1, and that's there, so that equals 0.6. So that's the actual change. And now I need this as a percentage change of the original amount. So I need to do 0.6 divided by 7.7 multiplied by 100. Okay, so let's do that on the calculator. 0.6 divided by 7.7 equals this, and then I'll multiply that by 100. Okay, and that equals 7.792%, which to the nearest whole number will equal 8%. Okay, great. Right, let's move on to the next question. Kasim wants to build onto his house. Okay, the diagram shows the part of his house and the centre of a tree. Okay, fine. This is his house. So we've got his house here, and we've got the tree here. Okay, 1 centimetre on the grid represents ... meters on the ground. The length of the house is 36 meters. Complete the key. Okay, so 36 meters is given to us by 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. Okay, so we know that 9 squares equals 36 meters. Okay, so I want to find out 1 square. So I'm going to divide this by 9. I'll divide this by 9. So 1 square is going to be 36 divided by 9. So let's do that here. 36 divided by 9. And that equals 4. So I know that 1 centimetre on the grid represents 4 metres on the ground. Let me take that and I will just shrink that and put it in the box. Here we go. Okay, so that's that bit done. Now let's see what they want about the next bit. The extension will be in the shape of a rectangle with a width of 10 meters and the same length as the house. Okay, so the roots of the tree grow in a circular shape. The roots will grow a maximum of 20 meters from the center of the tree. The extension will need deep foundations if built over the roots. Will the extension need deep foundations? Okay, right, so let's draw on this extension. So this is 4 meters. Okay, so remember 1 square is 4 meters. We need to get to 10 meters. 4 meters, 8 meters, and then another half of a square will take us to 2 meters because that's what we'll need for 10. So we need 4, 4, 2. That makes 10 meters. Okay, now it's the length of the house. So I can go the full length of the house here. And then I can draw down. Now the roots of the tree go 20 meters from the house. So this is 4. This is 8. This is 12. This is 16. This is 20. Okay. Okay, so this is 20 meters. Let's have a look here. I'm going to go this way as well. 4, 8, 6, 12, 16, 20. So that's 20 meters as well. Now, the way that it would work is this would be a circle like this. Okay. If you had a compass on you, you could use that to draw it. But I think freehand's pretty much good enough if you can see what's going on. So we can see here that there's going to be an overlap of the extension and where the roots of the house are. So we can confirm that the extension is going to need deep foundations. And the way that we've shown it is with our picture. Okay, so here we go. Yes. See picture. Okay, right. Tess works for a drinks company. She is told that it is better for the environment if less metal is used when making cans. She starts to design a new can that is taller and narrower than the old can. The new can is in the shape of a cylinder. It has a diameter of 52 millimeters, has a height of 154 millimeters, and holds the same amount of drink. Tess knows that 27,332 millimeters squared of metal is used to make the top, the side, and the bottom of each old can. She thinks that her new design will use less metal to make the top, the side, and bottom of each new can. Is Tess correct? Right, there's quite a lot to this question. So I'm going to need to just quickly go through this again. I can see it's about cylinders, and I can see it's probably about surface area of the cylinder. But I can't see the information about the old can. Right, so Tess works for a drinks company. She is told that it is better for the environment. Fine. Okay. She starts to design a new can that is taller and narrower than the old can. The new can is in the shape of a cylinder, has a diameter of 52 millimeters, has a height of 154 millimeters, holds the same amount of drink. Tess knows that 27,332 millimeters of squared is used to make the top, side and bottom of each old can. Okay, fine. So we just need to find out how much metal we're going to use to make the top, the side and the bottom of this new can. So we've got here this. We know that the circle has a diameter of 52 millimeters. Okay. We have that. So if we've got that as the top, now the bottom circle is going to be exactly the same. Now, if we think about a can has like this circular curved edge that wraps around it, okay? So if we unwrap that can, it is just a flat sheet of metal, which looks like this, okay? So let me just move this over here. Now this bit here has the height. So the bit that wraps around, the side of it is going to be the height. So this will be 154 millimeters. This dimension here is going to be the bit that wraps around. In other words, this length here is this length here. So this length is the circumference of the circle. So to complete this question, what we need to be able to do is we need to find the area, find area of top and bottom, of circles. Okay, now the area of the circle is given to us by pi times r squared, and in functional skills we always use 3.14 for pi. So this is going to be 3.14 times the radius squared. Okay, so in fact let's just do that now. If we know that the diameter is 52 millimeters, the radius is the word that we use to refer to half of the diameter. So we know that if the diameter is 52 millimeters, the radius will equal this 52 divided by 2. So the radius will equal 26 millimeters. So the area of the circles will be 3.14 times r squared, which is going to equal 3.14 times 26 times 26. And let's find out what that is. 3.14 times 26 times 26. So collectively, these bits use 2,122.64 centimeters squared, millimeters squared. Okay, so that's the area of one of those. So there's two of them, so we'll have to times that by 2. Okay, we'll remember that though. And then I'll write that number down there as well. Now the area of this bit here is a rectangle. So area of a rectangle is length times width. But before we can do the length times width, we need to find the circumference. So we need to know that the circumference equals pi times diameter. Okay, so remember we've got pi is 3.14 and we were told the diameter is 52. So in this case we're doing 3.14 multiplied by 52, and I can do those together here. So we've got 3.14 multiplied by 52, and that equals 163.28. So now what we've got to do is we've got to work out the area of this. So it's a rectangle, so it's length times width. So we're going to have to do 154 multiplied by 163.28. Okay, and find out what that gives us. So let's work this out. So we've got this number here multiplied by 154, and that equals 25,145.12. So what I now need to do is I need to add this number with this number and then this number again, because we've got top, bottom, area. Okay, so let's do that. We're going to have our final calculation will be 2514.5.12 plus 2122.64 plus 2122.64. And let's see what that gives us. Okay, so we've got 25,145. Add 1 second. Let's put in the decimals in case they make a difference. That equals 29,390.4 millimeters squared. Was this more or less than the old can? Oh no! So the new can design, to save metal, actually uses up more metal. Oh, that's a real shame. Yeah. Oh, what a pity. What a pity for the new can. So, no. New design uses more metal. Okay, right. Let's have a go at the next one. So here we go. Last week, 263 people passed their driving test at a centre. The table shows information about the number of people driving that took the driving tests before passing. Okay, what is the probability that a person chosen at random passed their driving test on their first attempt? Right, so we know that there's 263 people that took their driving test, and we know that 118 of them passed on their first attempt. So the probability of this is going to be, I'll just move that out of the way, it's going to be 118 out of 263. Okay, they haven't asked us to simplify this fraction, so we can just leave it as that. What is the probability that a person chosen at random did not pass their test on the first attempt? Okay, right, that's fine then. So here is the probability that they did pass their driving test on the first attempt. So the probability that they didn't pass their driving test on the first attempt is essentially everybody else. So we need to do 263, take away 118. Okay, so let's work that out. 263, take away, let me put my calculator back here. 263, take away 118. And this equals 145. So the probability that they did not pass their driving test on the first attempt will be 145 out of the 263. Okay, great. Next question. Keely sees a car she wants to buy. Oh, let me move the calculator. Keely sees a car she wants to buy. The purchase price of the car is £4,200. She can pay the purchase price in full, or she can use the payment plan. So the payment plan is here, and it says pay 2/5 of the purchase price today, 24 monthly payments of £112.90. Keely knows using the payment plan will cost more than paying in full. How much more will Keely pay using the payment plan? Okay, so first of all, we need 2/5 of the price. So 2/5 of 4,200. Okay, so 2/5 means 2 divided by 5. Of means times. So what we're essentially looking at here is 2 divided by 5 times by 4,200. Okay, so let's try that on the calculator. We've got 2 divided by 5. and that equals 0.4. So we're looking at 0.4 times 4,200, and we'll see what that equals. So 0.4 times 4,200 equals 1,680. So she's going to pay £1,680 straight away. Right, what's the next bit? So the next bit is 24 payments of £112.90. So we're going to want £112.90 multiplied by 24. Okay, and again, I've got my calculator for that. So let's work this out. We have 112.9 multiplied by 24. Okay, and that gives us £2,709.60. So we know that she's paying this in monthly instalments, and she's paying the 1,680 up front. So what we now do is we can add those together. So I'm going to add on 1,680, and that's going to equal £4,389.60. So I'll just make a note that I've done that. So 1,680 plus 2,709.60 equals 4,389.60. Okay, right. How much more is that than the purchase price? Well, what we now need to do is take away the 4,200 and see what that gives us. Okay, so minus 4,200 equals £189.60. So there we go. Question done. Right, let's look at the next one. So for this question, we've got Ryan is doing a project about sugar at school. He wants to compare the amount of sugar in grapes with the amount of sugar in cookie dough. Ryan finds this information. Grapes weighing 92 grams contain 15 grams of sugar. Cookie dough weighing 610 grams contains 110 grams of sugar. Ryan thinks there is a higher percentage of sugar in cookie dough than in grapes. Right, is he correct? Okay, so the way we need to do this is we write out these as a fraction. So we've got 15 grams out of the 92 grams in sugar. In grapes is sugar. And for cookie dough, we've got 110 grams out of the 610. So what we now need to do is we need to times these by 100 to calculate them as percentages. So remember, this line means divide. So let's do the grapes first. So this is going to be 15 divided by 92. So we can find out what that is. And then we times that by 100. And that equals 16.3%. Now let's do the cookie dough. 110 divided by 610 equals this. Times it by 100. Okay, and here we go. So that's 18% really to one decimal place. But we don't need to go too accurately because we can see that the cookie dough has a higher percentage of sugar than the grapes. So we can see that Ryan is wrong, which is a win for fruit. Right, Ryan is wrong. Okay, next question. Question 10. So here in this question, what we've got is an isosceles triangle. And it says it has a base of 13.9 centimetres and a perimeter of 18.2. Work out the length of side A. Right, okay, so if I know that the perimeter is 13.2, I know that the length of these two lines added together is going to be 38.2, take away the 13.9. Okay, so I can find out what that is on my calculator. And we've got here 38.2, take away 13.9. Oops, let's try that again. 38.2, take away 13.9. So that equals 24.3. Now, the thing about an isosceles triangle is that two of the sides are the same length. So I know that both of these sides are the same length. So what I can do is I can do 24.3 divided by 2, and that will give me the length of one of these sides. So if I divide this by 2, I will get my answer. And here we go. The answer is 12.15. Okay, let's have a look at the next part. Here are some calculations. Which calculation is a suitable check using estimation? So let's have a look at what we did. So I would say that this one is a good one. Oh no, is it 40 minus 10 minus 10? Yes, that is, because basically this is roughly 38, this is roughly 12, and this is roughly 12. Okay, so this would be an appropriate calculation where all of the things have been rounded to one significant figure. Okay, so I can do that. So this is the answer. So we'll say it is this one here and give that a tick. Is it just one that they wanted? Yeah, which calculation? Okay, yeah. So remember, the clue really with this one was that they all ended in 0. When we round to do estimations, we usually round to one significant figure, so you only really expect to see one digit within those. What? Okay, here we go. Write 6.8 as 6.8 percentage as a decimal. Okay, so to go from percentage to decimal, we divide by 100, and so this will equal 0.068. There we go. So I can do that on my calculator as well. 6.8 divided by 100 equals 0.068. Okay, right. I wonder if we'll be able to get this all done by Q2. We'll find out. Jess invests £3,800 into a savings account for 3 years. She will not put any extra money into the account. She will not take any money out of the account. The investment will earn 2.4% compound interest each year. Work out the total amount of interest after 3 years. Okay, right. So if you are earning 2.4% interest, that means every year you're going to end up with 102.4% of what you started. Now, in order to find 102.4%, what we do is we divide this by 100 to get it as a decimal multiplier. So that would equal 1.024. So now we've done this, any number that we multiply by 1.024 will increase that number by 2.4%. So what we're going to do here is we're going to work out 3,800 times 1.024 times 1.024 times 1.024. And this is for year 1, year 2, and year 3. Okay, so let's have a look at this. So we get 3,800 times 1.024 equals that, and then times 1.024, and then times 1.024. Hopefully I did all of that correct. And here we go. After 3 years, it will be worth £4,080 and 22 pence. We round it up to the nearest pence because it's pound and pence. So there we go. This will be the amount of money. Oh, work out the total amount of interest. Okay, so this is the amount of money that she's going to have. So now we'll need to take away the amount she invested to find out what this is as interest. So 0.22 minus 3,800. Okay, I'm going to just do this on my calculator again. So I'm taking away 3,800 from this number. And so that equals £280 and 22 pence. £280 and 22 pence. Okay, right. I think we might get through this. We're on page 24, so this is good. Right. Andy works at a medical centre. He reads a news report about a shortage of doctors in some parts of the UK. The report states the following figures. The average number of patients per doctor is 1,734. The range is 826 patients per doctor. The table shows some information about the number of patients for each doctor in the medical centre. Andy needs to write a report to compare the figures for the medical centre with the figures in the UK. He needs to comment on a comparison of the average number of patients per doctor, the consistency of the number of patients per doctor. Okay, so, we've got a choice here. We can either use the mean or we can use the median. Okay, so let's actually, maybe there's 6 marks here, so they might expect us to do both. So first, let's do the mean to start off with. So the mean is where we add all of these together and then divide it by how many there are. So we've got 1, 2, 3, 4, 5, 6 things here. So we're going to add these numbers together and divide it by 6 to get the average or the mean number of patients per doctor. So we've got 1, 3, 4, 8, add 1, 8, 4, 7, add 1, 7, 6, 0, add 1, 5, this is so slow, 1, 5, 6, 2, add 1, 2, 4, 0, add 1, 7, 0, 3. So we've added all of those together, so that's 9,460. So if I divide this by 6, because there's 1, 2, 3, there's 6 doctors there. That equals 1, I'm going to round it to the nearest whole number, 1577, okay? So the mean number of doctors here is 1,577. So I can see that that is lower than this, okay? So the mean, so let's say, we'll just say, first of all, make a comment there. The mean patients per doctor is lower at the medical centre. Okay, right, I'll be back in a sec. Quickly have a think about the Okay, right, so I said to quickly have a think about the median. So the median is the other form of average that we often use. Okay, so let's find the median. The median is when we put them all in order and we find out the middle value based like that. So I can see that this is the lowest. 1, 2, 3, 4, 5, 6. Okay, so when you've got 6 pieces of data, 1, 2, 3, 4, 5, 6, the median is the value that that comes in between the middle 2. Okay, so with this one, I can see the middle 2 are the 3rd and the 4th. So in that case, I've got 1562 and 1703. And if I want to find the median of these two, I've got to add them together and divide it by 2, and that's going to give me the median for this data. So here we go. Let's find my calculator here. So let's do 1562 add 1703. That equals this. Divide this by 2. 1632.5. Now let's have a look. Is that lower? And that is still lower. Okay. I can say the median patients at the medical centre is lower than the average. I should have probably said that here as well. The mean number of patients is lower at the medical centre than the average, because we don't know what type of average they have. Okay, now the last thing they wanted us to talk about was the consistency. So the consistency is, we use the range for this, and that the range is the difference between the highest and the lowest. Okay, so let me look here. So we've got the highest number of patients is this, and the lowest number of patients is this. So the range, we're going to calculate the range by doing 1847 take away 1240, and let's find out what that is. I'm going to do that on my calculator. So 1847 take away 1240, and that equals 607. Okay, so let's see. The range is 826. So the range here is more consistent as well. So this is a good medical centre. The number of patients per doctor in fact, let me just move that calculator. The number of patients per doctor is more consistent at the medical centre. Okay, right. Do I have any more questions? 25. Blank page. And that's it. We did it. Hurrah. Okay, well done, guys. That is brilliant. So that was the complete Edexcel paper for functional skills exam. So hope that was useful, and hopefully see you in another tutorial. Catch you soon. And